Could you imagine what would happen if you lost in jungle? Especially if this day was cloudy. None can find you and nothing can see you from above. This would in the past, thanks to SAR technology which can see you from above. SAR is a type of active data collection where a sensor produces its own energy and then records the amount of that energy reflected back after interacting with the Earth. What does this mean? In the past, we used to study Earth by capturing photos. This type of photos isn't the best option for its low quality and its ability to capture the required and the unclear surfaces. SAR was like a miracle for geology scientists and archaeologists. So, how does SAR work? SAR is a type of active data collection placed in satellite or airplane, where a sensor produces its own energy and then records the amount of that energy reflected back after interacting with the Earth's surface. The longer the antenna, the higher the quality. Scientists and archaeologists are using SAR data to help uncover lost cities and airplane type infrastructures hidden over time by dense vegetation or desert sands. SAR data can also enable an analyze method called interferometry or INSAR. INSAR uses the phase information recorded by the sensor to measure the distance from the sensor to the target. When at least two observations of the same target are made, distance with additional geometric information from the sensor can be used to measure changes in land surface topography. These measurements are very accurate, up to centimeter level, and can be used to identify areas of deformation from events like volcanic eruptions and earthquakes. Several new sensors are also planned for launch in the next few years. These include the joint NASA Indian Space Research Organization, SAR, NEOSAR satellite. SAR images also have wide application in remote sensing and mapping of surfaces of the Earth and other planets. Applications of SAR are numerous. Example include topography, oceanography, geology, and so on. SAR can also be used in forestry to determine forest height, biomass, and deforestation. Volcano and earthquake monitoring use differential interferometry. SAR can also be applied for monitoring civil infrastructure stability such as bridges. SAR is useful in environment monitoring such as oil spills, flooding, airplane growth, military and tactical assessment. The primary application of the remote sensing is analyzing the condition of rural roads, creating a base map of visual reference, combating snowpack, collecting Earth's picture from space, controlling forest fires, detecting land use and land cover, estimating forest supplies, locating construction and building alternation. SAR now is playing a great role in our daily life. Really, it's such a great important technology. Could you imagine what would happen if it wasn't found?